So you're playing D&D and you have a 20-sided die. During one evening's play, you roll this 86 times. A 1 is recorded as a miss. We're finding the probability that you get no more than 4 misses. So let's use X as, I'm going to say X counts the number of misses. So I'm going to just define a random variable I'm about to use. And I know that X is binomial. You could check your bin's requirements. And we would have a set number of trials. We rolled it 86 times. The probability of success on each trial is 1 out of 20. Of those 20 sides to it, only one of them has the number 1 in it. So now when I ask for no more than 4, well, the numbers that are more than 4 are the numbers 5, 6, 7. So anything 4 or fewer will be no more than 4. It never said it couldn't be equal to 4. So I'm going to use binom CDF so it can count these for me. So 86 trials, 1 out of 20. And then the X value I'm trying to include, the last one I want it to add for me is the number 4. And when I put that in my calculator, I get 0.5690, a little over half the time that should happen. How many misses should you expect? When I start talking about how much I'm expecting, this is my expected value. It's the same thing as the mean of my random variable. When it's binomial, this formula is just n times p, meaning if I'm playing 86 times and the success happens 1 out of 20, I just need a 20th of 86. So I'm going to get about 4.3 misses. That's what I should expect. If instead of rolling 86 times, your group decides to play until a miss is rolled, so no longer do we have the set number of trials, we now have a geometric distribution. So I'm going to define a new variable. I should probably say distribution, not variable. Which is fully defined by my probability success, which is still 1/20th. I'm still talking about misses, which is the number 1 on this die. I want to find the probability that I'm going to have to, I only roll the die less than 10 times. So I'm finding the probability that y is less than 10, which I'm just going to translate because I don't want to use non-equality in my calculator. I'm going to change it to less than or equal to a 9. The numbers less than 10 are 9, 8, 7, blah, blah, blah. So this would be geomet CDF to add for me. And all I need to tell my calculator is the probability of success and the value that I would like it to stop adding on its way up. So that 9. Ooh, that's not the right answer. I looked at the wrong line, sorry. That's the next question. This should be 0.3698. So then the probability that you roll the die at least 15 times, well, at least means that is the very least it's going to equal. Could be 15 or 16, but it will not be less than that. So it's everything that is not less than or equal to 14. This less than or equal to is how your calculator is programmed to use its CDF functions. So now that I have it in these terms, I can just say I'm going to use the geomet of 14. So geomet CDF, probability of success of 1/20th. The final X value I would like it to add is that 14, so I could take it away and be left with 15 on up. That's how I got the 4877. And then again, it asks about my expected value. How many rolls should I expect before a miss is rolled? When it's geometric, you have a different formula for this. It's just the reciprocal of your probability of success. So 1/1/20. So we should expect 20 rolls to get a miss. Now, I guess technically it says how many rolls before a miss is called. We expect the 20th roll to be the miss, or 19 before the miss is rolled. That's just a weird technicality. Don't worry too much about that. You should know the formula of each for a geometric and a binomial, and when each distribution should be